129.
So 16 on 129.
The problem will pack is 42.
On page 129?
Yeah.
So we want to look at 16?
Yep.
Use the definition of continuity and the properties of the limits to show that the function is continuous on the given interval. Okay. So we have 16 on page 128, correct?
Sorry, no, it's problem 42 on page 129, page 6 or number 16 in the packet.
Okay.
Um,
So we're going to look at 43 on page 129.
okay.
So in problem 43, we're given, remember, you should have done this from the recommended problems first before you look at the homework problem, right? Okay, so let's do 43. So f of x is x plus 2 for x less than 0, is e to the x for 0 to 1, and is 2 minus x for greater than 1. So this problem is asking us to identify the discontinuities, and once we identify them and we say discontinuous at such and such, to analyze what happens at those points, meaning if the function is continuous from the left or from the right or none of the above. Any questions so far? Okay, so first of all, I will graph the function. Obviously, this is negative infinity to 0. Obviously, this is 0 to 1. And this is 1 to infinity. We know this because we graphed piecewise defined functions from the beginning, correct? According to this, the function is defined on all real numbers. And then the next step is to get the chart going. Negative infinity to infinity. Of course, in the chart, I will have to have which values? Of course, 0 and 1, absolutely. Under 0, I have a parenthesis facing left and a bracket facing right. Under 1, I have a bracket facing left and a parenthesis facing right. Do we agree so far? I know that this is an overkill. I'm just trying to get you in the best habits. So this is x plus 2, and this is e to the x, and this is 2 minus x. Yes, it's an overkill, but just to make sure, sometimes these functions are not presented from left to right. So you may have to rearrange them in the chart, just to make sure you're not putting x values in a totally different function than you are supposed to. So far, so good?
Yes.
Okay, so then we have a negative 2, which will give us a 0. I have a 0, which will give us a 2. Have a 0, which will give us a 1. Have a 1 that will give us an E. I have a 1, which will give us a 1, and a 2, which will give us a 0. Is this okay so far? We agree? We possibly disagree, possibly agree? Yes, no, anything? Is this okay? Perfect. So now I'm ready to graph. So from left to right, the first ordered pair is negative 2, 0. The next one is 0, 2. And this is a straight line. Zero comma 1. 1 comma E. E is roughly 3, less than 3. So 1, 2, 3. So I'm going to say somewhere here. And this is the graph of e to the x. Then 1 comma 1 and 2 comma 0. And my conclusion would be that the function is discontinuous where? At 0 and at 1. Now let's analyze what happens at 0. Is this function continuous from the left of 0? No, because the function value and the limit from the left are not equal. Is this function continuous from the right? Yes, because f of 0 equals the limit as x approaches 0 from the right of f of x. That's why it's continuous from the right of 0. Is this function continuous from the left of 1? Yes, because f of 1 equals the limit of f of x as x approaches 1 from the left. So it's continuous from the left at x equals 1. Is this function continuous from the right at 1? No, because the function value and the limit are not the same. So two discontinuities at x equals 0 and 1, and the function is continuous from the right of 1 and is continuous from, from the right of 0 and from the left of 1. Is this better? Any questions on this problem? This was 43 on page 129. Is there anything else?
22 on 117.
22 on 117. Is it from the checklist?
No.
117, 117, 117, 117. 22, very good. Let's take a look. 22, we have, oops, I already wrote that. Limit as x approaches
1.5.
negative 3/2 from 9 minus x 4x squared divided by 3 plus 2x equals 6. Very good. So in this problem, we're asked to use the epsilon delta definition or the precise definition of the limit to show that the limit exists. Okay, first I have to plug it in to make sure that it's 6. So 4 times 9 over 4 would be, right, in this case, I can't have 0 at the top. In this case, I have to simplify it completely before I even check anything. So I will rearrange the top and the bottom in descending order, and I will completely factor. I can't plug in. I can't even check that it's 6. So I have to simplify. So then limit as x approaches negative 3/2, negative in front of the fraction line, 4x squared minus 9 over 2x plus 3.
Would it be plus 9?
Negative 1 times 4x squared, negative 1 times negative 9. Is that okay? Very good. You may see, always tell me if you see something because you may be right and I may be wrong. So I'd rather go back and check. So never be afraid to say something, anything. So limit as x approaches negative 3. So I have negative 2x minus 3 and 2x plus 3 divided by 2x plus 3. Obviously, I'm allowed to get rid of these. And now this is limit as x approaches negative 3/2 from negative 2x minus 3. And now I try again, and this better be 6. So 2 times negative 3/2 is negative 3. Negative 3 minus negative 3 is negative 6. And with minus in front is indeed 6. Therefore, I will write the equivalency, the double equivalency symbol. And I would say for every epsilon greater than 0, I will always find the corresponding delta positive such that every time I pick x very close to negative 3/2, delta close, f of x minus 6 will be less than epsilon. So one more time. For every epsilon greater than 0, I will find the corresponding delta greater than 0 such that every time I pick x very close to negative 3/2, the distance between x and negative 3/2 is less than delta. The distance between f of x, f of this x, minus the limit distance between f of x and the limit will be less than epsilon. Guaranteed. Is this okay? Yes? And I have to start from the end. So number one, I write the absolute value of negative 2x minus 3. I know that this is what I'm after. I need to create this. From here, I need to create this in order to find delta. So let's look at this inequality and come up with something. I know what I have to do. In order to get this 3/2, obviously I have to force a factor out. What factor I need to force out? Very good. What is left in parentheses? Awesome. What is left in parentheses? Very good. Now I have to use the property of the absolute value. The absolute value of a product is the product of absolute values. And then I'm done. So the absolute value of negative 2, the absolute value of x plus 3/2 less than epsilon. I have to state this step. And then I have the absolute value of negative 2, which is 2. So I'm going to continue here to the absolute value of x plus 3/2 less than epsilon. And now I know what I have to do, and I know delta. Yes, x plus 3/2 less than epsilon over 2. So can anyone give us delta? All you have to do is compare this to this, and you have the, oh. So this compared to this, and you have delta.
Delta is epsilon.
That's it. So if you say epsilon is 0.1, then I'll say I'll give you delta 0.1 over 2. If you say epsilon is 0.001, then I'll say it's 0.0001 over 2. And I also have to say, show that delta equals, oops, epsilon over 2 works. And we know what we have to write, one sentence. And it's fine. I'm fine with that. Good question. Thank you, Jason. Is it clear? I'm sorry?
Justin.
Justin, I'm sorry. I think I called you Jason before. This is not the first time. Maybe you should change your name. No, I'm sorry. Justin, I'm sorry. I apologize. With witnesses, this should count. More. Okay, anything else for me? Anything else for me? Okay, if you find something, I can always stop and go back to what you have for me. So 2.6, limits at infinity. Do you have anything? Did you find anything else for me? I'm hoping that you keep up with the checklist and you're done, including 2.5. So there are 3 more sections left, 6, 7, and 8. Yes? Yes? Okay. So when we talk about limits at infinity, that's exactly what we are talking about, limits at infinity. So I'd like to go back to the checklist for a minute to show you where we are. I just had one open right here, yes. Okay. So the limit of f of x as x approaches infinity, if that is a number, and I'll show you examples right now, then y equals L is a horizontal asymptote at infinity. So we cannot really conclude, depending on the function, we cannot always conclude that the limit to infinity and negative infinity is the same. We cannot. So we may have to study both, depending on the question, depending on the problem. Okay? So let's write this if you would like. So if limit as x approaches infinity or x approaches negative infinity, depending on the function, is a number L, then y equals L is a horizontal asymptote. And I have selected several examples in the limit document. And I'd like to select a couple of problems now. On page 141, and see how we deal with this. Yes, yes, if it's a number. If the limit of a rational function is 5, when x approaches infinity, then y equals 5 is a horizontal asymptote. Yes. We discussed this in pre-calculus, but we did not prove it entirely. We did prove it, but not with limits. So now this is what we're trying to do. We're going to prove this with limits. Before we choose an example, I would like to ask you common sense. What will this equal to? And you should say, let me think for a moment. I know the graph. The graph is this and this. So I'm asked to find the limit of 1 over x as x approaches infinity.
0.
Right, absolutely. Right? Because the top is 1 and the denominator is infinity. And I always give this silly example. Let's say I have a cake and I want to share it with everyone on the planet. By the time I get to your door, how much is it left for you? Nothing, right? So 1 divided by huge is 0. The same thing with limit as x approaches infinity from 1 over x to a power. As long as the power is positive, this is also 0. Now what if I change this into negative infinity? Still the same thing. Okay, so let's look at a few situations with limits at infinity. So if you want, I can let you choose.
What's the abbreviation y equals L is
Horizontal asymptote. Sorry about that.
26.
Yes.
The second, sorry, bottom right. What's the it's x?
This is R.
Oh, it's r.
R is the power of x as long as it's a positive number. Because, here's why. If it's a negative number, it goes to the top, and the answer will no longer be 0. Very good. And I should have that on my checklist. Let's take a look. Here it is. Limit of 1 over x to the r is 0 if r is a number greater than 0. And when a limit as 1 over x over r as x approaches negative infinity is still 0, as long as r is a number greater than 0. So you have this under number 30, and you have it also under number 29. Okay? So which one did we pick?
What was the page?
Page 141.
26.
So we want to look at 26. Perfect. 26 on page 141. So we have limit as x approaches negative infinity from x plus the square root of x squared plus 2x. Okay. Before we look at this problem, I would like you to refresh our memory or answer the following question. How many cases of indeterminate, how many indeterminate cases have we encountered so far?
3.
Indeterminate case. Yes. Which one?
0 over 0.
Only 0 over 0. We did not see anything else yet. So at the very end of the checklist, if you have it with you, I hope you do. Last page. Let's put a check mark next to the first, at the very bottom, page 21. Let's put a check mark next to 0 over 0, because we've seen this before. And what did we say about 0 over 0? That there is hope. There is no guarantee that the limit exists. But if we encounter 0 over 0, there is hope for the limit to exist, correct?
Yes.
Okay, perfect. So that's all we encountered for now. There are total of 7, 1 product, 1 difference, 3 powers, and 2 ratios. 1 product, 1 difference, 2 ratios, 3 powers. Okay? Good, so let's continue. So let's take a look at this limit. I'm given a limit and I'm asked you to determine it. What do I have to do first? I tried to do that here, but I couldn't. But I had to do it. And I tried to plug it in. I got 0 over 0. It's not 6, so I have to do something about it, which I knew I had to factor and simplify. So what do we need to do? And the answer is still plug it in. And you can say infinity or negative infinity. Yes. Yes. So when x approaches negative infinity, what does this quantity approach? Perfect. So what type of number is this? So let's forget about the square root for a moment. I have x squared and 2x. And x approaches a huge number. It happens to be negative. Which of these two quantities will be the leader? No, 2x is too small. X squared is much bigger. So then x squared is in the lead. As x approaches negative infinity, what is the sign of x squared? What is the sign of the square root of a positive number? So let's go back to the end of the checklist. For such a situation, we cannot conclude. You cannot say 0. So this is the second encounter. This is a second indeterminate case. And when we say indeterminate case, we mean anything can happen. 0 can happen, E can happen, 1500 can happen, just anything. It's an indeterminate case. So this is our second encounter, second indeterminate case. Okay, good. So then, what can I do? I have to think of something that will remove the indeterminate case. So we encountered so many situations with this, and what did we do? We simplified, we rationalized, we what else, ever else we did. So now what do you think we're going to have to do here? Yes, both of you. You can say it at the same time.
Can you just go over 2x and infinity? How you got?
Yes. So from x squared and 2x, which one is more powerful at infinity? Which one grows faster? Does x squared grow faster when x approaches infinity, or does 2x grow faster when x approaches infinity? Yes, x squared is bigger. It will overtake 2x. No matter what 2x is, x squared will dictate. So therefore, this quantity is a positive quantity. Huge, positive. When I take the square root from it, I still get huge, positive. If this quantity would have been positive infinity, the answer would have been very simple. What? That's it. If both of these two are negative infinity, the answer would have been very easy. Done. Right? But since I have negative infinity plus infinity, there is no answer.
That's because x plus the square root is always positive, right?
Say it again.
Because x plus the square root is always going to be a positive, that's why it's negative.
This quantity is positive, but this one is not.
Okay, it's negative.
When x approaches negative infinity, x approaches negative infinity. So the graph of this is this. As x goes to negative infinity, y goes to negative infinity. So, what do we do?
Could you technically plug in like any number?
I cannot. Nope.
Yeah, say factor, but
You can't?
yeah, rationalize.
Of course. When you see a radical like this, so you have to rationalize. There's no other way. Good. So please tell me, what do I multiply it by? Of course, and divide by.
X minus square root.
Of course. Very good. I should have not done that, and I'm going to delete it. So what do we have at the top? Can anyone give us Be very careful with the top. You either give me parentheses or you distribute correctly. So please tell me what to write.
X squared.
Awesome.
X squared minus
Exactly.
X squared plus 2x.
Very good. Awesome. And the denominator, there is nothing you can tell me. It has to be this for now. Good. I go back to the top. And what is left at the top, please? Very good. Yes. Do you all agree that at the top it's x squared minus 2x, and the quantity remaining at the top is negative 2x? Do we all agree? So x squared minus 2x. X squared with minus x squared go away, so I have minus 2x. Good. Let's take a look at the denominator. One more time, what is the degree of this expression? 2. Since the degree is 2, I'm going to force out an x squared. Still under the square root. I can't do anything just yet. So because the degree is x squared, if the degree were x cubed or 3, I would have factored out x cubed. If the degree were x to the 4 or 4, I would have factored out x to the 4. But since the degree is 2, I factor out x squared. So please tell me what is left in parentheses.
1 plus 2x is negative 1.
Perfect. Very good. So indeed, let's check this. X squared times 1. X squared times 2 over x. Simplify 1x and you get 2x. Is this okay? Okay. Next step. Yes, but I have to think. I have to think. So let me write it first for everyone to see. And then we have to decide, what does the square root of x squared equal to? And let me back up for a second and say, do you remember in general, what does this represent? It represents the absolute value of x, which is x if x is greater than or equal to 0, or is, yes, if x is less than 0. Okay, so let's go back for a second. The square root of x squared is not x. Because if x is negative, then this would be a negative number. So the square root of x squared is the absolute value of x. Because I have to guarantee that this number is positive. This is always positive, no matter what. Then this has to be always positive. Furthermore, now, I know that the absolute value of x could be x if x is positive, or it could be negative x if x is negative. Just to simplify this. But this is always positive. So if x is positive, then I get positive number. If x is negative with minus in front, will still be positive. Right? This portion is extremely important. This piece of information is extremely important because now you are going to tell me correctly what is the square root of x squared going to be replaced by. And you cannot answer before you look here where x is going. And you cannot answer before you look here where you identify where x is going. So what do I replace this piece, not this, just this piece by?
Negative x squared.
Not negative x
Negative
squared,
x.
just negative x. So this piece will be replaced by negative x. So now I copy the top again. I have negative 2x. And now can anyone give us the bottom?
X plus x.
Awesome. Good. Now, I will factor out the degree. Disregard this for a moment. What is the degree now? 1. Yes. So I'm going to factor out x. Of course, all these steps are necessary because I need to get rid of this. And I need to get rid of this. So then,
So what the x?
yes? Because x times 1 is this and x times this is this, correct?
What about the second x?
The inside I can touch.
No. Aren't there two?
Yes, x times 1 is x. X
Oh.
times the square root is x the square root. This is not plus, this is multiplied.
Yeah, he's talking
Very good.
about the
Yes.
addition sign.
Very good. So now what do you think I'm going to do? Right, but I have to ask myself, can I simplify by x? What if x is 0? How can it be? Look at where it's going. It's so far away from 0 that I don't have to worry about it. And now I am ready. Let's do this together. Only at this stage, if you drop the limit operator anywhere down the line, you have to put it back in. This is the moment where we drop the limit operator. Okay, so let's do this together. As x approaches negative infinity, where will this go?
0.
0. So then the inside is the square root of 1, which is
1.
plus 1.
2.
The numerator is negative 2 and the denominator is 2. What is the limit?
-1.
Would you have believed that from the beginning?
No.
Nope. So this is an indeterminate case. No one can figure this one out. What the outcome would be without those steps. I would have not been able to tell you any of that without going step by step. So we conclude that y equals -1 is, but I have to be very specific. At exactly, because we didn't even look at infinity. Now let's look at infinity, just for the sake of the argument. So we had limit x plus the square root of x squared plus 2x. What is this limit as x approaches infinity? Of course. There is no calculation, there is no horizontal asymptote at infinity.
You also want to do that?
Unless the problem is asking us. Is it clear? There is no indeterminate case. This approaches infinity, this approaches infinity, infinity plus infinity is infinity. There is no horizontal asymptote at infinity. There is only one horizontal asymptote, which is y equals -1 at negative infinity. Okay, this was a very involving type of problem. I let you choose. That was my mistake. I should have started with a simple, more human example. So I'm going to do a more simple and more human example. And here it is, 18. So limit as x approaches negative infinity. Once you choose, I'm stuck. I have to finish it. I have no choice.
I have a question.
Yes. Yes.
So I mean, if you went through all the steps for infinity, even though I know you don't need to, wouldn't it come out the same as it did negative?
We wouldn't know that y is -1.
What was it? X plus
The square root of x squared plus 2x.
what is the other function that I have to present because the calculator will not do it? Y equals?
Or
Of course, of course. Okay. The limit of this function as x approaches negative infinity is the limit as x approaches infinity of this function is
It's the, I forgot about the absolute value.
The absolute
equal to
value.
Negative x. That would be switched.
good, very good question. So let's take a look at number 18. Number 18 should be a piece of cake because we've done this in pre-calculus without doing anything. Can anyone refresh our memory? What is the limit as x approaches negative infinity of this function without doing anything? Exactly. The leading coefficient over the leading coefficient because both top and bottom have the same degree. So we really don't need calculus for this, but let's do it. What is the degree at the top? Let's factor it out. What is left in parentheses?
4 plus x, 6x.
6 over x minus
2 over x cubed.
cubed. What is the degree of the bottom? What is left in parentheses?
2 minus 4x.
4 over x plus,
5 over x cubed.
good. I simplify this with this. Now please tell me when x approaches infinity or negative infinity, where does this go?
0.
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 And what's the limit? 4 over 2, 4 over 2, which is 2. So then y equals 2 is what?
Horizontal class.
We did this in pre-calculus, but I could not use the limit operator then. But I did the exact same steps. I'm sure Paul remembers this, and Nico remembers when we factored out the degree. But I didn't tell them why, because in the sense that I didn't use the limit operator, but we did the same thing. Okay, let's also look at something with exponentials, like for example 34. On the same page 141. 34. Okay, limit as x approaches infinity from e to 3x minus e to negative 3x over e to 3x plus e to negative 3x.
Maybe down a little bit.
Oh, sorry. Okay. So let's take a look and plug it in and please tell me what you get, top and bottom. So both 26 and 34 are part of your checklist. So I'm fine with that. It's not a problem. But I just want you to know that.
E to 6x.
So when x approaches infinity, where does this go?
0.
Perfect. Where does this go?
0.
Perfect. Where does this go?
Infinity.
Where does this go? So where does this go? Correct. So this is the third type of indeterminate case that we are looking at. Here it is. Here's the third one. So we had 0 over 0. We had infinity minus infinity, and now we have infinity over infinity. Very good. So again, anything can happen. It's an indeterminate case. Let me see, did we reach an hour? No, we didn't. Setting it?
That's not negative.
No. So e to a huge number is infinity, e to a huge number is infinity, e to negative 3x is 1 over e to 3x, which is 0. So this is 1 over e to 3x. Because it has a negative exponent, it brings it down. So 1 over infinity is 0. And this way, this one thing as well, 1 over infinity.
What about the other negative, e minus?
Infinity minus 0 is infinity. Infinity plus 0 is infinity. Is that okay, everyone? Okay, very good. So again, in this particular situation, we will try to factor out something. So I would like to factor out e to negative 3x from the top and from the bottom. Obviously, this will be 1 and this will be 1. But can you tell me what we get? So let's look at just discuss for a second. If we factor out e to negative, let's discuss which one is better. So if I pull out e to negative 3x, indeed this will be e to 6x, and this will be e to 6x, and this will work fine in the next chapter when we have what is called L'Hopital's rule. But here I would rather factor out e to 3x. Because if I factor out e to 3x, then I would have 1 minus e to negative 6x, and that would be much easier to conclude the limit. So I'm going to change that. I mean, both work, but one requires the L'Hopital's rule, and we don't have that till the next chapter. That will be easier. So I'm going to pull out the positive. And then, can anyone tell us what we have left? Of course, this is 1 and 1, no question about it, because we pulled out e to 3x. So when I factor out e to 3x, then I have e to negative 3x over e to 3x. Let me write this for you. E to negative 3x divided by e to 3x. I copy the base and subtract the exponents, and I get negative 6x. So that's why I get e to negative 6x and e to negative 6x. And of course, you know what I'm going to do next.
Math.
Yes. Simplify e to 3x, that was the whole purpose.
I'm sorry, can you go over how you got e to negative 6x?
Correct. So remember when we were here for a moment, and we said the degree is 3. So I pulled out x cubed. X to the third times 4 is this. X to the third times 6 over x will be 6x squared. And x to the third times negative 2 over x cubed will be negative 2. In the same way, we do this. So I pulled out e to 3x, so there is a 1 left. So then this one, exactly. So e to negative 3x divided by e to 3x, copy the base, subtract the exponents. From negative 3x, I subtract 3x, and I get negative 6x. Is that better?
Yep.
Okay, perfect. These two go away. Where does this go when x approaches infinity? Yes. Where does this go when x approaches infinity? Is this clear why it's approaching 0? Because e to negative 6x is 1 over e to 6x. As x approaches infinity, this becomes infinity, and 1 over infinity approaches 0. So when x approaches infinity, e to negative 6, or e to negative infinity is 1 over infinity, which approaches 0. So then what is left is 1 over 1, so the answer is 1, which means y equals 1 is horizontal asymptote. Yes, I would say at infinity, but this function, it doesn't really matter. But I'll say at infinity, because we haven't checked the other one. Very good. Other questions here before I select a problem for finding all asymptotes? This is a complex problem, not a difficult problem, but this is extremely useful for the next chapter. So let's look at 43 on 141. It says, find the horizontal and vertical asymptotes of each curve. I will have to add, and also the limits, the corresponding limits, because I don't want you to say, oh, the horizontal asymptote is 1. No, I want you to show why it is 1. Okay? So the function given in 43 is f of x equals 2x squared plus x minus 1 divided by x squared plus x minus 2. You can already say right away that this function has a horizontal asymptote of 2. But it's not enough. We have to show the limit. Okay? It's a rational function. It will have the same horizontal asymptote. There is no question about it. So you can say, you can find the limit of f of x as x approaches infinity or approaches negative infinity. You don't have to do it twice. I'm happy if you just present that. And that shows me that you know that the function will have only one horizontal asymptote. Okay, so this is limit as x approaches infinity. I see what I have to do. What is the degree at the top? Yes, so I have to factor out. What is the degree in the denominator? Good. And what do I have in parentheses?
1 over x.
So this is 2 plus 1 over x minus,
1 over x.
that's it. And the next one is 1 plus 1 over x minus 2 over x squared. Yes, these two go away. These all four go away, so the answer is as expected, 2. So it means y equals 2 is a horizontal asymptote. So we're done with the horizontal asymptote. Now I'm coming back to this function. I will factor it. Less than numerator, I don't really care for it. Unless, maybe I shouldn't say that. I'll take it back. So I have to factor both the top and bottom if possible. I spoke too soon. I'll explain why I spoke too soon in a minute. So I need to factor the numerator. Let's start by factoring the denominator because I need this to dry out. So what is the what are the factors in the denominator? So potentially, I have to write, first of all, I have to write two restrictions. And potentially, the function may have two vertical asymptotes. We'll see in a moment. Very good. Awesome. So potentially, I'm not sure yet, but potentially this function has a vertical asymptote at x equals -2 and one at x equals 1. But I also have to show and calculate the limits. However, I have to go back to the numerator. How do I factor the numerator? There is a 2 in front.
2x plus 1, x minus 1.
I think it's -1 and plus 1. So let's check. 2x squared plus 2x minus x and minus 1. If I put positive here, then I will have minus x. Okay, why did I say that I spoke too soon? Here's why. If any of those factors from the top were this or this, the function would have not had a vertical asymptote there because the factor would have gone away. And what would have been the answer? An open point. An open point. But 2x minus 1 is not here. X plus 1 is not here. Now I guarantee, and I know for sure that these two are vertical asymptotes. So let me put a side note. So assuming I had 2x minus 1, x minus 1 over x plus 2, x minus 1. if that were the case. X equals 1 is a whole. X equals negative, because I can simplify it. The condition still remains. And x minus 2 will be a VA. But that was not the case. That's why I said I spoke too soon, because I wanted to show you that these two at the top are none of them is the one from the bottom. So now I know for sure, guaranteed, x equals negative 1. So this is not the case. Not the case. So I don't want you to get confused. So x equals negative 2 and x equals 1 are VAs. But that's not enough. I need to determine the limits left and right of 1 and left and right of negative 2. And then the problem is complete. The solution is complete. So I have to find limit of 2x minus 1, x plus 1 over x plus 2, x minus 1 as x approaches negative 2 from the left.
So
Yes?
earlier in the problem, we found the limit is x to infinity justifying the horizontal.
Yes. Yes. So the horizontal asymptote always goes with limits and infinity. The vertical asymptote always goes with when the function is undefined, not when it has a hole, although we need those limits too. But when it has a vertical asymptote is where it's undefined and the factor does not go away, and I have to find the limit left and right for all vertical asymptotes. So the next one will be limit as x approaches negative 2 from the right of 2x minus 1, x plus 1 over x plus 2, x minus 1. And of course, two more. Limit as x approaches 1 from the left, 2x minus 1, x plus 1 over x plus 2, x minus 1. I'm okay if you want to determine this with the graphing calculator, but it's too easy to even bother with the graphing calculator. But it's up to you. It's a lot of writing anyway. Yes, I agree. So let's do this together. Ready? Negative 2 from the left. Well, I know all these answers. What I don't know is the sign. I know this. Once I establish that x equals negative 2 and x equals 1 are vertical asymptotes, the left and right must be infinities. But what I need to establish is their sign. So let's establish the sign. Negative 2 from the left is negative 2.1. Negative, 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 negative. Done. It's not warranted to put this in the graphing calculator and stop punching in. Negative 2 from the right is negative 1.9. Uh, 0.9. 1.1. Let me see if I have an error here. 0.9. 0.9. Yes, I do have an error. So 0.9. Yes. 0.9. Yes. Any questions? Go ahead. Any questions? Yes, please.
You're just entering in the numbers, right?
I'm sorry?
You're just entering in the numbers.
A number negative 2 from the left. Negative 2.1.
So you're just
Negative 2.1, negative 2.1, negative, negative, positive. Because there are 4 negatives.
Could you do me a favor?
Yes.
For when I come back to this, could you just put for under negative 2 and then negative put 2.1 under it? You know what I mean? Like what you plugged in as opposed to.
Any number that is close enough to negative 2.
So maybe you can use like 3, right?
No, too far. Yes, some of them are too, yes. We have to be very careful because there may be whatever happening. I don't know. So negative 2 from the left, negative 2.1, negative 1.9, 0.9, 1.1. Any questions here? Any questions?